example 4, the quadratic function is f of x is equal to 3x squared plus 6x plus 2. Okay, so obviously this is a quadratic function. It's a polynomial with the highest power of x being 2. We can go ahead and identify the a, b, and c. So a is the number in front of x squared. So here a is 3. B is the number in front of x, it's 6. And then c is the constant, it's 2. A is positive, so that means when we graph this thing out, it is going to open up. Okay, so it's going to look something like this. Okay, so all our work had better agree with this, that the parabola opens upwards. Okay, let's start by trying to find the vertex. Okay, so we know the vertex is going to be an ordered pair. It's going to tell us where to center our parabola. Okay, so to find the x-coordinate of the vertex, we need to use the vertex formula, that x is negative b over 2a. So we're just going to plug in here. So we're going to get negative b, that's going to be negative 6 over 2 times a. So that's going to be 2 times 3. Okay, and so that gives us negative 6 over 6, which is negative 1. Okay, so the x-coordinate of the vertex is going to be negative 1. And then we can use that number to calculate the y value of the vertex. So we just need to take the x value of negative 1 and plug it into the original function, okay, which I just highlighted in yellow. So we know f of x is the same thing as y. So we just need to plug in negative 1 for x. So we're going to get 3 times negative 1 squared. If you square negative 1, that means you're going to multiply it by itself, plus 6 times negative 1 plus 2. Okay, so again, all I did was go to the original function in yellow. Everywhere I see an x, I replaced it with negative 1. Okay, so if we simplify this, this is going to tell us that y is going to be 3 times negative 1 times negative 1. If we look at this little piece, negative times negative will be positive. So this is going to be positive 3. 6 times negative 1 is negative 6. And then we tack on the plus 2. So if we go from left to right, 3 minus 6 is negative 3. Plus 2, that's going to be negative 1. Okay, so the vertex is at a nice point. It's at negative 1, negative 1. That is right here, okay? Since this parabola opens upward, this is going to be the lowest point on the parabola, okay? All right, let's go get the x-coordinates, or sorry, the x-intercepts, okay? So we know to find the x-intercepts, we need to set the y value equal to 0 in the original function and solve for x. So let's go ahead and do that. So if you look at the yellow equation here, y is the same thing as f of x, so we're going to get 0 is equal to 3x squared plus 6x plus 2. Okay, we need to solve this quadratic equation. So we know our options are to factor or to use the quadratic formula. Okay, when I worked example 1 and example 2, I factored. So I'll do example 3 and example 4 by the quadratic formula. Okay, but it's your call. It's whatever you feel that you're more comfortable with. Okay, all right, so we know the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, it's the same a and b, the a, b, and c that we identified initially. Okay, so let's go ahead and plug into this. Okay, so we will get that the solutions to this equation are going to be negative b, so that's going to be negative 6 plus or minus the square root of b squared, so that's going to be 6 squared minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Okay, we need to simplify it. Okay, so let's do that. All right, so let's leave the negative 6 plus or minus. Let's figure out what's under the square root. Okay, so under the square root, 6 squared is 36. And then we have minus 4 times 3 is 12 times 2 is 24. And the bottom is 6. And so then let's see, under the square root, 36 minus 24 is going to be 12. And then the bottom is still 6. And Okay, we got to simplify this. We don't know the square root of 12 off the top of our heads. Okay, but let's go ahead and try to simplify it. We've talked about how to simplify square roots when we did circles. Same rule applies. So if you make a factor tree for 12, this breaks down into 3 times 4. 3 doesn't break down anymore, but you can break 4 down into 2 times 2. Okay, and then the 2's don't break down anymore. So here you go. Okay, so if we want to rewrite the square root of 12, we're going to rewrite it as the square root of 2 times 2 times 3. Okay, we have a pair of 2's, so we can take one out, and then that leaves 1 3 under the square root. Okay, so the square root of 12 is the same thing as 2 times the square root of 3. Okay, so here we go. Okay, I'm just trying to simplify the x-intercepts. They are crazy numbers, but I'm just trying to simplify it. Okay, they're not nice numbers. So we're going to have in the numerator -6 plus or minus the square root of 12 is the same thing as 2 times the square root of 3. Okay, so I'm going to make that replacement. The bottom is 6. Okay, now we can break it up. Okay, I've told you this before. The correct way to break up a fraction is to take everything in the top and divide by the entire denominator. So we need to do -6 divided by 6 plus or minus 2 square root of 3 divided by 6. Okay, so then this is going to become -6 divided by 6 is -1 plus or minus, okay, you cannot do anything with that square root. You cannot multiply the 2 through. You cannot divide into it. It just stays the square root of 3. But you can reduce the 2/6. 2 goes into 2 one time. 2 goes into 6 3 times. So this becomes the square root of 3 over 3. Okay, these are the x-intercepts. Okay, there's 2 of them. One based on the plus sign, one based on the minus sign in the middle. Okay, this looks totally crazy, but this is the answer. Okay, all right, we're going to have to graph out the x-intercepts. Okay, so we do need to go to the calculator to get a decimal approximation here. So the first x-intercept, I'll call it x1. Okay, and we're going to approximate it. Well, hang on, I'll do that. I'll put the approximately symbol once we punch it into the calculator. Okay, so let's first choose the plus sign in the middle. So -1 plus the square root of 3 over 3. Okay, let's go to the calculator to approximate this x-intercept. So we're going to get -1 plus the square root of 3 divided by 3. Okay, so this gives you an approximation for the x-intercept. So we'll just round it to -0.42. Okay, so that means the first x-intercept is approximately at -0.42. That's the x value. The y value will be 0. If we had to draw that on our graph, you know, it's going to be a negative x value. It's going to be somewhere between 0 and -1. So maybe right here. Okay. All right, so the other x-intercept, okay, you can get by choosing the minus sign in the middle. So x2 is going to be equal to -1 minus the square root of 3 over 3. And let's go punch it into the calculator to approximate it. We're going to get -1 minus the square root of 3 divided by 3. Okay, so we will just round this one to -1.58. All right, so this time the other x-intercept is going to be at -1.580. Okay, if we had to draw that on the graph, the x value is going to be a little over halfway between -2 and -1, so maybe like right here. Okay, so again, we've got a vertex that's very close to the x-intercepts. Okay, these x-intercepts, like I said, they're not nice numbers. Okay, but that, you know, most of the time when you're working with a parabola, you may not have nice numbers in real life. Okay. All right. So here we go. We need to finish the work up here. We need to go back and try to find the y-intercept. Okay. So to find the y-intercept, we're going to go back to the original function. We're going to set the x value equal to 0 and solve for y. Okay. So if we go up to the yellow equation, we know that f of x is y. Okay. So we're going to plug in 0 for x, we're going to get 3 times 0 squared plus 6 times 0 plus 2. Okay, so this is going to be 0 plus 0 plus 2. That's just 2. So you have a y-intercept at 0, 2. Okay, so if we take a look at the graph, okay, here is the y-intercept at 0, 2. Okay, if we go ahead and draw in the axis of symmetry, remember it is going to be a vertical line through the vertex. The vertex is at -1, -1. Okay, so here's your axis of symmetry. Remember, the parabola has to be symmetric about the axis of symmetry. So the bad news is it's kind of good news and it's kind of bad news. We didn't actually need the x-intercepts to graph this thing. The x-intercepts were crazy. We could have just gotten the y-intercept, had the vertex, the y-intercept, and then said, hey, this y-intercept is at 0, 2. It is 1 unit to the right of the axis of symmetry. So if I fold my sheet of paper, it's going to go 1 unit to the left. So -2, 0. Well, or sorry, I said the wrong coordinate. Hold on. Let me change that. This point right here is also going to be on the graph. It has coordinates -2, 2. Okay, so we ended up with 5 points on the parabola. That's okay. The more the merrier, the better it'll look. Okay, so here we go. The parabola will look like this. Remember, the vertex absolutely has to be the lowest point on the graph. Okay, and then it goes up forever in both directions. Here's your parabola. Okay, so key points, -2, 2, 0, 2, and then the vertex is -1, -1. Okay. All right, let's go ahead and write down the axis of symmetry. Okay, it's the green dotted line. We know it's a vertical line, so it's going to be x equals, and it's going to be x equals the x coordinate of the vertex. So that's going to be x equals -1. Okay, every point on the green dotted line has an x coordinate of -1. Okay, domain of a parabola is always all real numbers. Okay, if we're looking at the range, we're going to write down y values. We want to go from the lowest point to the highest. The lowest point on the graph is the vertex. It has a y coordinate of -1. We're including that y value because it's got a closed circle there. And then the highest point on the graph is positive infinity. Okay, so there's the range. The y values are -1 or bigger on the parabola. Where are we increasing and where are we decreasing? Let's go from left to right. Okay, so if we go from left to right, we're falling to the left of the axis of symmetry, and we're rising to the right or increasing to the right of the axis of symmetry. Okay, so let's go ahead and write down that information. So we'll do increasing first. Okay, so increasing, that's on the right side of the vertex or the right side of the axis of symmetry. You start increasing at the vertex. Okay, the vertex has an x coordinate of -1. Okay, and then you go to the right. Okay, that's going towards positive x values. Okay, so this parabola is increasing for x values -1 or bigger. Okay, on the left side of the axis of symmetry, that's where you're decreasing. Okay, so you're decreasing over negative x values up until the vertex, which has an x coordinate of -1. Okay. All right. So last thing we got to do is look at the inequality that I've given you. Okay. It says, for what values of x is 3x squared plus 6x plus 2 less than or equal to 0? Okay. So just like we've been doing in all of these, we know the answer has to be x values. Okay, so answer must be x values. Okay, so then when you look at this, okay, 3x squared plus 6x plus 2, that's the original function. Okay, if you go back and look at this yellow statement, okay, 3x squared plus 6x plus 2 is f of x. Okay, this inequality is saying when is f of x less than or equal to 0? Okay, if you translate, this means when is y less than or equal to 0? Okay, so we need to write down the x values that have negative y values. negative or 0 y values. Okay, because your inequality symbol here is less than or equal to. Okay, so we're looking for negative y values or 0 y values. Okay, so we know that negative y values occur below the x-axis. Okay, so the question becomes for which x values is the parabola below the x-axis. Okay, well, if I go back up to my graph, okay, I'm going to mark in red where the parabola is below the x-axis. Okay, this little piece right here. Okay, so basically in between the two x-intercepts. Okay, so we need to write down, to answer this question in part C, we need to write down the x values between the two x-intercepts. Okay, so we have to use interval notation here because you could be at some decimal x value. Okay, you know, if you see where my cursor is, if you're like right here, if you're at this x value, then the y value is going to be negative. Okay, so you've got to write down all the x values in between the x-intercepts. Okay, so be careful here. We had some crazy looking x-intercepts. I'm going to draw right here. Okay, this x-intercept, it's the one that's negative 1.58. Okay, so this ordered pair here is negative 1 minus the square root of 3 over 3. That's the x value, and then the y coordinate is 0. So that's the ordered pair there. And then if you look at this x-intercept, this is the one that was like negative 0.42. So the x value here was exactly negative 1 plus the square root of 3 over 3. Okay, the y coordinate is 0. Okay, so basically, if you're writing in interval notation, you have to go from left to right. Okay, so if you're walking along the number line, you would first hit the x-intercept negative 1 minus the square root of 3 over 3. And then later you would hit the one on the right, which is negative 1 plus the square root of 3 over 3. Okay, and we're going to use interval notation. Okay, all x values in between these two x values. Okay, so the question becomes, do we use parentheses or brackets? Okay, so do we include the x-intercepts themselves? Okay, x-intercepts have y coordinates of exactly 0. Okay, if you look at the inequality, y needs to be less than or equal to 0. Okay, so we are going to include the x-intercepts because their y coordinates are exactly 0, and that's okay according to the inequality. So we're going to put brackets. Okay, this is your answer. This interval enclosed with brackets with crazy numbers inside. Okay, so again, all that is saying, okay, is the parabola has negative y values or 0 y values in between and including the two x-intercepts.